Hi algebra students, this is our introduction video for our lesson on solving systems by substitution. A quick review of some of the vocabulary we have learned. We have learned that anytime you see the word system, it means in this class that we are talking about two equations, and those two equations would have the same solution. When we use this word today, substitution, remember substitution means replacing. Usually when we substitute, it means, for example, we know x equals 2, and we're replacing the number 2 for our x in our equation. It usually looks something like this. We can use substitution as a way to solve system of equations. And so, for example, if I have a system of equations, so far we have learned one way to solve this system is by graphing. If you graph both of the lines, you can find where those lines intersect. But we don't want to have to graph every single time we solve systems. And so there are ways algebraically you can solve. And one way is by substitution. In order to use substitution, we need either x equal to something or y equal to something. And here, it doesn't look immediately like I have that, but I do. One of my equations says y equals, so I have exactly what I need. The difference here compared to what we've done in the past is y doesn't equal a number, y equals 2x plus 1. This is a great opportunity to use colors or different colored pens to help show what we're going to do. Because y equals all of this, it means I can replace y in my other equation with all of that. So I'm going to be putting 2x plus 1 in place of y right there. And so when I substitute, my new equation says 2x minus 3, because the only thing I'm replacing is y, and then that y changes to 2x plus 1, and I'm going to make sure I have parentheses around that. And then the rest of my equation equals 5. Now, looking at this equation, this is great because my equation only has x in it. So the next thing I can do is I can solve the equation. Go ahead, pause the video, and solve this equation now for x. Here's my work. So the first thing I did was I distributed -3. Make sure you include that sign. And it gave me 2x minus 6x minus 3. Then I combined like terms. 2x minus 6x gives us -4x. Next, I get rid of my constant. I add 3 on both sides. And then I divide both sides by -4. And here is my answer. X equals -2. Now, when we think about solving systems of equations, think back to when we were solving by graphing. Our answer was always a point, which means here, my answer, or we can call it solution, my solution is also going to be a point. My solution is going to look something like this. So right now, I only have my x. I only know the -2. So I'm not done because I still need to find y. And so the way we do that in this last step here is we are going to substitute again to solve for the other variable. And so if I look at my two equations, I can use either. For me, because I'm trying to find y, this first equation that says y equals looks a little easier. So I'm going to say y equals 2, but instead of x, I'm going to substitute. Instead of x, I'm going to write -2. And then the rest of my equation plus 1. And then this is my last step. I'm going to solve this equation, and it'll give me my y. To finish solving this, y equals 2 times -2 is -4, and -4 plus 1 gives me -3. And so that y coordinate is -3. This is what solving systems by substitution looks like. It's going to be a lot of substituting, which should make sense because that's the name, a lot of replacing, and then just solving equations, which we learned back in pre-algebra, and so that'll be a great review. I've got one other example down here solving this system of equations. Now looking at this one, it looks a little different because we said step number 1 is we need x equals or y equals. And here we do not have that. What do you think we're going to do? Well, you know how to solve an equation for a specific variable, so you could take either of these equations and solve for one of the variables. My advice, I could take the first equation, and solving for x looks a little easier because x is already by itself, there's no number in front. Or I could take the second equation and solve for y, the same idea, y is already by itself. I'm going to go ahead and I'll do the first one. If I solve this equation for x, I'm going to subtract 2y on both sides, and that gives me x equals 10 minus 2y. And so my new system, my first equation is this, and then my second equation is 3x plus y equals 10. Go ahead, pause this video and try solving this the same way we solved this first one. Use these steps here to help you solve, and then come back to the video to see how you did. Here's the first part you would need. So when you substitute all of this in place of your x here, it's going to look like this equation here, where all I have left is y. You know something's not right if you try substituting and you have x's and y's still. That's a red flag. But when you solve this equation, here's my work, and we get y equals 4. If you've got y equals 4, you're on the right track. Go ahead, pause the video, and finish solving for your x coordinate. Okay. When you go to solve for x, we're substituting y equals 4 into an equation. I do want to point out, you could use either of our original equations, or you could use that equivalent equation for the first one. All of these will give you the same solution. I used our new equation, the one that said x equals, just because I know I'm trying to solve for x. And when I solved it, I got x equals 2. So our final answer, our solution, would be the 0.24. We will be doing more practice on this today in class. Thank you so much for watching.